All right, so I was just reviewing one of my GitHub repos and noticed this Azure pipeline's failed. That's no good because I've got PR validations and everything. It should never fail. So when I click on it, I'm surprised to see that it's my latest CI actually failed. If I look at the history, sure enough, it's been really good until this point. And I look into the failure, and there's this: an internal error occurred, failed while generating an external method. An item with the same key has already been added. Now, the way this works, this error in the build is actually an error in my product, because what happens is CsWin32 builds, and then we use that to build other projects, including the spell checker, which is a sample that demonstrates using CsWin32. So this internal error from pinvoke0000 is actually a bug in my source generator. I haven't seen this bug before, though. And it's surprising that it got checked in. When I review this, I see this was a batch CI that failed. The PR that led into it succeeded. Now, the first clue is the PR that went into it was share metadata index instances across multiple generators. That will be relevant. But I also wanted to see, like, is CI just totally botched? So I've got another pipeline here where I can see it that same CI on this other account, but that same commit actually passed. So whatever we're looking at, it's an unreliable, it's a non-deterministic failure, which makes sense since it managed to get into main. So now let's look at this error more carefully. An item was added to with the same key, and it conveniently gives me the key type. So there's a dictionary. Unfortunately, this error doesn't include the exception call stack. That would be wonderful to have. But it does give me this. And this turns out that this is very, very useful. So I'm going to copy that out. And here in the source tree, the solution, I'm going to search for that. I'm going to search for dictionary of type reference handle. And lo and behold, there's only one, which is marvelous. And so if I search for references to this, there's a try get value. So I'm checking to make sure that this thing isn't there already. And then if I scroll down a little further, there's the add. Oh, in fact, this is actually what the fix. Ha, my bad. So let's go back to this. Okay. So it adds. Now, at face value, this looks fine, right? We only add if it wasn't already in the dictionary, so how could this possibly be failing? So I spent a little bit, like a couple minutes, looking around, trying to figure out if there was something I was missing. And then it occurred to me, well, is there some way for add to be called between this point and this point? And it turns out there is. In fact, the PR that went in just before this error showed up was moving this method from the generator class to the metadata index class. And the metadata index class is shared by many generators. So generator doesn't have to worry about thread safety because we new up a generator and we run it. We never do multi-threading or anything with it, and then we shut it down. And this cache that we're producing used to be at the generator level. But now that it's the metadata index, which is just recently started being shared across generators, many generators could call this method at a time. And so if two threads were both calling this method at the same time with the same type ref handle, they both could get past here. One of them could get to the add point before the other one does, and the second one's going to fail. So that's pretty good. But there's one other problem to this, though. Even if so I could check it again, right? I could do try get value right before add or something. But there's another risk, which is you really, really don't want to be using a dictionary concurrently without locks, because dictionary will get into a spin when there's data corruption. But if you're mutating the dictionary from one thread and mutating it or reading from another thread, you can actually get threads that will never exit. They'll call into the dictionary and hopefully they'll throw. Usually it'll throw, but sometimes it'll actually get into an infinite loop, which will stall your program, and that's no good. So you really want to be careful with the dictionary. You don't want to use a dictionary outside of locks if it's in multi-threaded code. So one option was to change this dictionary like access it within a lock all the time. So I lock here, and I would lock there. That doesn't solve the double add problem though. So within the lock, I would have to check to see is it there yet, and if it is, so that's optimistic locking basically. I lock it, see that I need it, unlock, do my third, my complex code that shouldn't hold a lock while I'm doing it. And then just before I stick it in, I'll enter the lock, I'll check one more time to make sure it's still not there. And if it is there, I'll just drop my value and use theirs or use mine and not add it, whatever. In this particular case, though, I chose, instead of adding locks, I would add concurrent dictionary, or I would switch this to a concurrent dictionary. So there you go. That's very similar. I actually had very little code to change. The only thing I needed to do was change it from add to try add, which is a smart way of saying, if it's not already there, stick it in there. Now, the reason I did that is because I do want this to be fairly concurrent code, and locks would potentially slow me down a little bit, and concurrent dictionary actually is fast. When you're doing a lot of reads and very few writes, concurrent dictionary is faster than a dictionary with locks. So that turned out to be the better call in this case. The other thing I did to make future bugs easier to investigate, because I got lucky. There was only one dictionary that time, so it led me straight to the problem. I wanted a call stack for next time, though. So here is the method that I use to produce the error, the p in bug 000 error in my source generator. And right now, what it does is it looks at the outer exception and copies the message, and then it goes to each inner exception and appends more and more messages. So you get this nice general error message like what we saw here. Internal error occurred, failed generating this method, an item was already added. You just kind of progressively get natural language for humans to understand this was the overall problem down to the very precise problem. What I'd really like to do is have a call stack after that. So after my loop that adds progressively inner exceptions to the message, I then start a new line and I'm going to print out the entire exception output. So it'll repeat the messages in context of each exception's call stack.